This is section 4.4, or part of section 4.4. So I kind of broke up all the applications into different sections, and so these applications specifically use the substitution method that the previous video talked about. So in this example it says the width of a rectangular garden is 5 meters less than twice the length, which is kind of a mouthful. We'll look about that more in a minute. The perimeter is 80 meters. What are the dimensions? So the first word we want to look for here, we have a rectangle. So if we draw just a simple little rectangle here to help us visualize what we're doing, just kind of set up the problem. We also know, I'm going to skip over that for a minute, it also says the perimeter is 80 meters. The perimeter of a rectangle is 2 times the length plus 2 times the width. So we have length here and here, so that's where the 2L comes from. And then we have width here and here, that's where the 2W comes from, and if we add up all 4 sides, that is the perimeter. So it says the perimeter is 80 meters. That's the first thing we know. We know the equation for perimeter, 2L plus 2W, and I'll give you that part on the exam. And the tough part of this one is that middle phrase, 5 meters less than twice the length. So we know we have a 5. We know we have less than, which is a subtraction. We have twice the length. The tricky part is when we come to subtraction, we talked about the word from in chapter 2. When we see the word from, then whatever comes after it goes first. It's the same idea here. Anytime you see less than, whatever is after less than has to go first. So we take twice the length and then take away 5. That would be 5 meters less than twice the length. So the width, W, equals twice the length minus 5. So we actually have to swap the order. So when we see the word from, we swap the order. And when we see the word less than, we swap the order. So we know the width is 2L minus 5, and we know the perimeter is 2L plus 2W. So our two variables here are L and W, and we have 2 equations. The first equation, I'm going to replace the perimeter with 80, because we know the perimeter is 80. So we know 80 equals 2L plus 2W. We know our total perimeter is 80. We also know that the width is 2 times the length minus 5. And that's the hardest part of this problem, is to set up your problem. I call this the setup. Draw yourself a picture. This equation is the most important to get correct. And then you set up your 2 equations. Once you have your setup and your 2 equations, then you can see the substitution. So we have W equals 2L minus 5. So now we're going to make our substitution into the first equation. We have 80 equals 2L plus 2, and then I'm going to replace W, 2L minus 5. And once we've made the substitution, we just work it out. So 80 equals 2L. 2 times 2L would be 4L, and then 2 times negative 5 would be minus 10. And then we combine like terms. 2L plus 4L would be 6L minus 10. Then we solve for L. 90 equals 6L, divide by 6. 90 divided by 6 is 15. So that's one answer. This part should be just like the previous video. Once we have one answer, we're going to plug it back into either one of the original equations. The second one would be a little bit easier. W equals 2L minus 5. We just figured out that L is 15. So W equals 2 times 15 minus 5. 2 times 15 is 30, minus 5. Our width is going to be 25. And we're going to have both answers. So the dimensions are asking for length and width. So we have the length is 15, and the width is 25. And I think it's measuring in meters. So put a little m for meters. So on your test, I'll have 2 blanks, 1 for each dimension. Go ahead and pause the video, try example 2. It's very similar, not so tricky with the subtraction. Try example 2, set it up, get your 2 equations, and then start to work it out. So on this one it says the length of a rectangular sign is 3 feet longer than twice the width, and the perimeter is 108 feet. And again, what are the dimensions of the signs? So it says rectangular, so I'm going to draw my little rectangle for my setup. It says the length is 3 feet longer than, so adding, we don't have to worry about the order, twice the width. And we know the perimeter, which is 2L plus 2W, is 108 feet. So our 2 equations are the one for length and the perimeter equation, and I'm going to take off the p, don't need that because I know the perimeter is 108. So my equation will be 108 equals 2L plus 2W. So from here, I'm going to make my substitution. L is isolated, so L equals 3 plus 2W. So I'm going to substitute in that where I see L in the second equation. So 108 equals 2 times 3 plus 2W plus the 2W from the rest of the equation. And then go ahead and work out the algebra. So 108 equals 6 plus 4W plus another 2W. So 108 equals 6 plus 6W, and subtract 6. 102 equals 6W. Divide by 6. Let's see what 102 divided by 6 is. I got 17. So the width is 17. That's one answer. I'm going to go back and plug that in. Let's see. I'm going to use the first equation. It's a little bit easier. I'm going to pull that out over here. So L equals 3 plus 2. I know W now is 17. 2 times 17 is 34. And 3 plus 34 is 37. So we have our 2 answers, and you'll see the 2 blanks again on your test and on your homework. Length is 37, this is measuring in feet, and width was 17 feet. So 2 answers. So just a couple applications that set up as substitution. Now we're going to move on to the second type of solving systems, and that is with something called elimination. So now we're on page 9 of our notes. This is section 4.3, and then we'll get into some applications in section 4.4. Solving systems with elimination and some applications. So this method is useful when none of the coefficients are 1 and or all of the equations are in standard form. And by all of, we're just looking at 2, so both of the equations are in standard form. Remember, standard form is your AX plus BY equals C. So when x and y are on the same side of the equation for both equations, this method works a little faster. So in other words, if neither variable is easily isolated, so we talked about if it just takes one move to isolate a variable, substitution's a little faster. If nothing can be easily isolated, then this method is better, elimination. The idea of this method is to combine the equations together, or add is the word your textbook uses, add the equations together in a way that eliminates one of the variables in order to solve for the other. So your textbook calls this the addition method. So you'll probably see that in your notes, or if you watch any textbook videos, it's called the addition method. Most other textbooks refer to it as the elimination method, but you're doing both. You're adding and you're eliminating, and you'll see that when we get to our example. So you'll see this called two different names, but it's the same procedure. So again, we're going to go through the steps just like we did in section 4.2, and then I'll walk you through an example as we talk about each step. So your first step is to put both equations in standard form. And usually they're already like that, but you want to make sure everything's nice and lined up. You want to make sure your x terms are first, and then your y terms, and then your constants. And so you'll see in this example, all your x terms are lined up first, your y terms are lined up second, your equal signs are stacked, and then your constants are by themselves. So you want to make sure everything's kind of vertically lined up here. At this point, step 2, this takes a little bit of work usually. Either the x or the y variable's coefficients need to be the same integer with opposite signs. The same integer with opposite signs, so one positive, one negative. And I put a little note, this usually requires some work. So the first couple of examples, this part will be done for you, and then we'll talk about how to get there if it's not done for you. So if you look at this example, we have 2x and 2x. It's the same integer, but they do not have opposite signs. If you look at the y term, we have positive 2y and negative 2y. Here we have the same integer, 2 and 2, with opposite signs. One is positive, one is negative. So 2x plus 2y equals 14. 2x minus 2y equals 10. And so if you want to highlight what it is we're looking for, this is what we're looking for in step 2. We're looking for the same coefficient with opposite signs, the same number with opposite signs. Once we have that, our next step is to draw a line under the bottom equation and vertically add the like terms, or combine the like terms. Add or combine the like terms. This should eliminate one of the variables. So this step looks kind of strange at first, but you're going to draw a vertical line under your two equations. We're adding them together, or combining them, and we're going to add vertically. So 2x plus 2x is 4x. Positive 2y plus negative 2y is 0y. And then 14 plus 10 is 24. So 0y is like it's not there. And so what we really have is 4x equals 24. And you'll notice it eliminated the y variable, just temporarily so that we can solve for x. Just like when we did the substitution, one of the variables disappeared. Here we're doing elimination or addition, and one of the variables is disappearing. The last few steps are going to seem very familiar. Step 4, you solve for the remaining variable, so that's an easy step. Just divide by 4. X equals 6. And then you can probably guess the last couple steps here. Once we solve for that variable, we're going to take that answer. That's one answer. We're going to plug in that value back into one of the original equations and solve for the other variable. So you can pick the top equation or the bottom equation. You guys know by now that I like positive numbers, so I'm going to pick the top equation. 2x plus 2y equals 14. I'm going to plug in 6 for x, so 2 times 6 plus 2y equals 14, and then I'm going to solve from there. 12 plus 2y equals 14, subtract the 12, bring it over here, that's going to give me 2y equals 2, divide by 2, and y equals positive 1. Again, the work here gets a little messy, just like I did in the other method. So your final step is to state your answer as an ordered pair. So no matter what order we solved it in, we're going to put x first and then y. So remember, that's always x and then y. So the last three steps are the same idea. You solve for the variable you have, plug it in to get the other one, and then write your answer as an ordered pair. Let's look at some examples of the elimination method. If you feel comfortable, you can pause the video at any time and try one. So I encourage you to pause the video now and try example 2, and then we'll go through it. Looking at example 2, the first thing we want to make sure of is that they're both in standard form. Notice the x's, and then the y's, and then the constants are all lined up, and your equal signs are lined up. The second thing you want to look for are the coefficients. We need to make sure they're the same number with opposite signs. So we have negative 3 and positive 3 here, and positive 3 and positive 3 there. So the x's coefficients are all lined up and ready to eliminate. Then we'll draw a vertical line and add. Sometimes we call that stack and add the equations together. Negative 3x plus positive 3x is going to eliminate the x's. You don't even have to write 0x if you don't want to. Positive 3y and positive 3y is going to be positive 6y, and 6 plus 24 is going to give you 30. So really all you have is 6y equals 30. Then we'll solve for y. That solving's usually very simple, just one step. We get y equals 5. From there, our job is to plug that into one of the original equations. I like positive numbers, so I'm going to pick the bottom one. It doesn't matter. I'm going to replace y with 5. So you can plug it into either equation. It's going to give you the same answer, because remember, we're looking for the one point that these two lines share. So 3x plus 15 equals 24. Move your 15. 3x equals 9, sorry. And then divide by 3. X equals 3. From there, we're going to state our solution as an ordered pair, x and then y. Looking on at example 3, we've got a little different of a situation here. Both equations are in standard form, stacked up nicely. The x's are first, then the y's, then the constants. If we look at the coefficients, the x's coefficients are different. The y's coefficients are the same, but they're both negative. So now we have to do a little bit of work to make them opposite signs. We can either multiply the first equation by negative 1 or the second equation by negative 1. It does not matter at all which one you choose. I'm kind of looking at the constants here, and maybe if we make the top equation positive, that'll help us add, but it truly doesn't matter. So it's totally your choice. I'm going to choose to make the top equation positive by multiplying everybody by negative 1. We kind of did this in chapter 3 when we were trying to write things in standard form. When you rewrite your equation, I recommend writing it to the right of the original, not below the original, because we have to stack and add, and that makes it a little confusing. So when we have to change the way the equation looks, we're not really changing the equation, but just the way it looks, we're going to write our new one off to the side. So negative 1 times negative 2x is going to give us positive 2x. Negative 1 times negative 9y is going to give us positive 9y. Negative 1 times negative 25 is going to give us positive 25. We're not going to do anything to the second equation, but I encourage you to write it again exactly as you see it underneath your new one. It's important to keep things vertically together, so even if you have to rewrite something again, that's okay. It will help you keep everything organized. So that step sometimes requires some work, and it's just up to you. What you do whatever it takes to get those coefficients to have the same number but opposite signs. You can multiply by whatever you want to make that happen. Kind of like when we get common denominators. It's the same idea. And we're going to add these together. Positive 2x plus negative 4x is negative 2x. The y's eliminate. You can even cross them out if you want to. And then positive 25 plus negative 23 is positive 2. And we're going to divide by negative 2. We're going to get x. Positive 2 divided by negative 2 is negative 1. And there's one of our answers. Now our job is to go plug into one of the original equations. You can use either one of the originals. You can even use your new one if you want to. They're all positive numbers, so you can do that. But it doesn't matter at all. I'm going to go ahead and use the top original equation. You can pick a different one if you want to. I'm going to plug in negative 1 where I see x. So negative 2 times negative 1 minus 9y is negative 25. It's going to be positive 2 minus 9y is negative 25. Subtract 2, negative 9y equals negative 27. Divide by negative 9. We get y equals, that should be positive 3. And we'll write our solution as an ordered pair, x first, and then y. Alright, I encourage you to pause the video and try example 4 on your own, and then play it back and see how you did. It's very similar to example 3, and then we'll go through it. Looking at example 4, we're both in standard form, all stacked up. That part's usually done for you. We have positive 2 and positive 2, and then 7 and 8. So I'm going to choose to make the top equation negative by multiplying everybody by negative 1. I'm going to rewrite my new equation to the side. It's going to be negative 2x minus 7y equals negative 24. And then here is just 2x. I'm just going to copy it over so that everything's stacked up the way I like it. Then we will draw our line, stack and add. It's going to eliminate the x variables. Negative 7y plus 8y is just going to give us y, or you can write 1y if you want to. Negative 24 plus 30 is going to give us 6. So we should just get the answer. We don't even have to divide. Then we're going to plug that into either one of the original equations. I like even numbers, so I'm going to plug this into the second equation. 2x plus 8 times 6 equals 30. So that's 2x plus 48 equals 30. I'm going to move the 48. So 2x equals positive 30 minus 48 is negative 18. And divide by 2. And there's my second answer. I'm going to write my two answers. I like to circle them so I can find them as a solution, x and then y. I'm going to stop there, and I will continue the next examples in the next video.